Hello everyone. I am going to discuss about crystal field theory. So what is crystal field theory? Crystal field theory is used to describe the bonding in coordination compounds and to rationalize and predict their properties. So it was first proposed by Hans Bethe in 1929. So before going to discuss what is crystal field theory, I want to tell about the assumptions on which this crystal field theory is based on. So as we know, the coordination compounds are formed between the interaction between a metal atom and some ligands, different types of ligands. So in crystal field theory, the first assumption is that the interaction between the metal ion and the ligand is electrostatic in nature. And secondly, the ligands which gets coordinated to the metal center are treated as negative point charges. So before going to discuss the splitting, crystal field splitting, we have to know about the shapes of d orbitals, because in case of transition metals, the mm, central metal atom is a transition metal atom, and the valence orbitals of the transition metal atom are d orbitals. So there are a total of 5 different types of d orbitals. Here I am showing the pictorial representation of all these orbitals. These are denoted as the x square minus y square, the z square, the xy, the yz, and the xz. So if we look into these orbitals, the first, the x square minus y square and the z square, their orbital lobes are pointing directly towards the coordinate axis. Whereas in case of these other 3 orbitals, the orbital lobes are in between the axis. So let us consider the crystal field splitting in case of octahedral complexes. In case of octahedral complexes, there are a total of 6 ligands gets coordinated to the metal atom. Here I am showing a typical Ml6 compounds. And if we look into this figure here, in case of the free ion, all the 5 different types of d orbitals are degenerate in nature, that is their energy are same. So first of all, if we consider a spherical field where all the metal center is gets influenced by the ligand environment spherically, that is equally from all the sides, their energy gets raised. However, their degeneration does not break, that is their energy remains same. So however, if we consider the octahedral field, their degeneracy breaks and they form 2 different sets of orbitals. One is denoted by T2Z set of orbitals, which includes the xy, the yz, and the xz, and the other set includes the x square minus y square and the z square, and it is denoted by EZ. So why these 2 different types of sets are formed? So as I have already mentioned that in case of the dx square minus y square and the z square orbitals, the orbital lobes are pointing directly towards the coordinate axis. So as a result, when the ligands approaches towards the metal center, their energy raise, and to maintain the very center, the other 3 orbitals gets destabilized. So total amount of crystal field splitting in case of octahedral complex is denoted by del naught or 10 dq. So if we consider a typical tetrahedral complexes, just like I have shown here, ML4, here the ligands approaches the metal center, uh, not directly towards the coordinate axis, but in between them. So as a result, dx square, dy, the xy, yz, and dzx, d orbital gets destabilized, whereas the other 2 orbital gets stabilized. Here this splitting is denoted by del t, and the crystal field splitting in case of tetrahedral complexes is less than compared to the octahedral complex, because the number of ligands in case of tetrahedral complex is less than the octahedral complex. So mathematically del T is equal to 4 by 9 of del naught.